Okay, good morning students. Now we just see the amplitude modulation. Now its derivatives DSB, SC, SSB, VSB, right? We finish all these things, right? Now we'll see one step move to that. So what are the problems which we are faced in amplitude modulation? Okay. Now finally, because in all amplitude modulation and its counterparts are the information is available in terms of amplitudes. Now which means that the effect of noise is more because the information itself in terms of amplitude. Okay. So now we go for the next modulation level, now which is nothing but angle modulation. Maybe I think this is the first time you are hearing the word angle modulation. That's what I am writing nearby that. Now this is FM modulation. Okay. So FM modulation, I think there is no confusion, but when angle modulation there is a confusion why angle modulation is called. Okay. So anyway, we will see why angle modulation. Before that, this is frequency modulation. Okay. Let us assume what is frequency modulation. Now what is the definition of frequency modulation? Okay. Now see here, frequency modulation. First of all, what is the frequency modulation? What is the definition? This is the message signal. This is the message signal. Frequency of the now this is a message signal amplitude AM. This is minus AM. Peak amplitude is AM, minimum amplitude is minus AM, frequency is FM. You know that. This is the message signal which is a low frequency information signal which cannot transmit it for the longer distance. Then we'll take the help of carrier. This is the carrier. Peak amplitude is AC, minimum amplitude is minus AC. This is a high frequency signal, therefore time period is very less. Right. Now what is a modulation? Okay. Now this is the message signal and this is the carrier signal. To modulate we required a high frequency signal. Now this is the carrier. This is carrier before modulation. Now we will see carrier after modulation. Now what is the peak amplitude of the carrier after FM modulation? Now this is not amplitude modulation, this is frequency modulation. In frequency modulation there is no change in amplitude. So this is the peak amplitude of the carrier is AC, minimum amplitude of the carrier is minus AC. There is no change in amplitude of the carrier after FM modulation. Okay, now see here. Now amplitude of the carrier before modulation is AC. Amplitude of the carrier after FM modulation is also AC. There is no change in amplitude. Is it right now? There is no change in amplitude. Now what is the frequency of the carrier before modulation? FC. What is the phase of the carrier before modulation? Phi. Now the amplitude of the carrier before modulation is AC. Amplitude of the carrier after FM modulation is AC. There is no change in amplitude. Now there is no change in phase, then what is changes? The changes in frequency. Now there is no change in amplitude, but there is a change in frequency. Now see here time period is very less. I am writing here. Why you write only the time period is very less here? Now if you observe here, so here the amplitude is maximum. So here time period is very less, means frequency is maximum. So can I say this is Fi, instantaneous frequency of the carrier after modulation, Fi maximum. So here time period is very high, means frequency is very less. Why only at this particular place frequency is less? Because here amplitude is very less. This is the instantaneous frequency of the carrier after modulation. Okay, so this is minimum amplitude, frequency is minimum. Maximum amplitude, frequency is maximum. So now this is the frequency modulation. There is no change in amplitude as well as there is no change in phase, only the change in frequency. But this frequency is continuously changing in accordance with amplitude of the message signal. This is Fi1, Fi2, Fi maximum, Fi3, Fi4 and so on. Okay, note on this. Okay, now this is the instantaneous frequency of the carrier after FM modulation. This is the instantaneous frequency of the carrier Fi3, Fi4, Fi5 and so on. Now here message signal amplitude is 0, so Fi which is equal to Fc. Now see here, the amplitude of the carrier before modulation is AC, amplitude of the carrier after modulation is also AC, no change in amplitude, there is no change in phase, only the change in frequency, but this frequency is continuously changing in accordance with amplitude of the message signal. Here message signal amplitude is maximum, therefore carrier instantaneous frequency is maximum. Message signal amplitude is minimum, instantaneous frequency is minimum. Message signal amplitude is 0, instantaneous frequency is Fc. So everywhere the carrier frequency is changing. This is carrier before modulation, this is carrier after modulation, unmodulated carrier, modulated carrier. What is the difference? The modulated carrier means any one of the carrier characteristic parameters are to be changed. Here amplitude is not changed, phase is not changed, but a frequency is one of the carrier characteristic parameter is changing. Therefore this is frequency is changing. This is frequency modulation, FM wave in time domain. Okay, this is the time domain waveforms, message signal, carrier signal and modulated signal. Now see here, this is carrier before modulation, carrier before modulation. This is carrier after modulation, unmodulated carrier, unmodulated carrier, modulated carrier, unmodulated carrier, modulated carrier. Now this is carrier before modulation. Which modulated carrier? Frequency modulated carrier. This is frequency modulated carrier is nothing but FM, frequency modulation. Okay, frequency modulated carrier which is nothing but FM. Now this is C of t. What is C of t? Carrier before modulation AC cos 2 pi FCT plus phi. This is carrier before modulation. Amplitude is AC, frequency is FC, phase is phi. Now I want to find first, before this, what is the instantaneous frequency of the carrier? What is Fi? What is Fi? Fi is instantaneous frequency of the carrier. Instantaneous frequency of the carrier. Now, first of all, you understand the frequency modulation. Amplitude is not changed before and after. Phase is not changed before and after. Frequency of the carrier is instantaneous frequency of the carrier is changed in accordance with amplitude of the message signal. Everywhere the message signal amplitude is changing, everywhere the carrier frequency is changing. Instantaneous frequency of the carrier is varied in accordance with the amplitude of the message signal is called as frequency modulation. Now, what is this instantaneous frequency of the carrier after modulation? Can I write like this? Fi, which is equal to Fc plus this frequency of the carrier is changed in accordance with amplitude of the message signal. This is the amplitude of the message signal. But what is the units of Fi? Fi units are hertz frequency. This is hertz, okay. This is also hertz, okay. But this is the signal variation. The signal variation means it may be a voltage variation or a current variation, right? Now the units are not matching. Therefore, now there is a parameter which is used here. This is Kf, and Kf is saying that I am hertz per volt. Therefore, this volts cancel and everything, it will be units are matching. But what is Kf? You know, the similar one we can appear in AM. Ka, sensitivity of the amplitude modulator. Here Kf, which is nothing but sensitivity of frequency modulator. This is the sensitivity of frequency modulator, hertz per volt or hertz per ampere. Hertz per volt or hertz per ampere. Okay. Now this is a sensitivity of the frequency modulator. Okay. Now this is Fi, instantaneous frequency of the carrier. Now you see here, you concentrate. When m of t is maximum, means Fi is maximum. When m of t is minimum, Fi is minimum. So message signal amplitude. Now m of t is maximum, so Fi is maximum. M of t is minimum, Fi is minimum. Sir, when m of t is 0, now here message signal amplitude is 0. When m of t equals 0, Fi equal to Fc. Is it right or not? So here message signal amplitude which is equal to 0, so Fi equal to Fc. So when m of t equal to 0, when m of t is equal to 0, then Fi which is equal to Fc. Now message signal amplitude is changing, then only the carrier frequency is changing, otherwise there is no change in the carrier frequency. Okay, no doubt. The instantaneous frequency of the carrier after FM modulation, Fi which is equal to Fc plus Kf into m of t. What is m of t? You know that. The message signal m of t which is equal to am cos 2 pi fm into t. Now see here, what is Fi? Fi which is equal to Fc plus Kf. M of t is am cos 2 pi fm into t. Now Fi maximum. What is Fi maximum? Fi maximum which is equal to Fc plus Kf into am. Cos 2 pi ft maximum is 1. Fi equal to Fc plus Kf into am. So Fi minimum which is equal to Fc plus Kf into am. Minimum value of cos is -1. Therefore Fi minimum which is equal to Fc minus Kf into am. This is Fi minimum. Fi maximum, which is equal to Fc plus Kf into Am. This is the maximum instantaneous frequency of the carrier after modulation, minimum instantaneous frequency of the carrier after modulation. This is Fi maximum, this is Fi minimum. Now see here, now before modulation frequency is Fc, before modulation frequency is Fc, after modulation that carrier frequency is deviated by an amount of, how much the carrier frequency is deviated? The carrier frequency is deviated by an amount of Kf into Am. The carrier frequency is deviated by amount of Kf into Am after modulation. So this deviation is called as frequency deviation. The frequency is deviated, therefore this is called as frequency deviation by an amount of, the frequency deviation is represented by delta F, the frequency deviation delta F, which is equal to Kf into Am. So what is the units of? This is hertz, hertz per volt into volt, volt cancel, this is it. This is the frequency deviation. So this is the frequency deviation Kf into Am. So frequency deviation units are hertz. So this much amount of frequency is deviated after modulation. Understand not? And practically the maximum frequency deviation is, the maximum frequency deviation is 75 kilohertz maximum. Practically the maximum frequency deviation is 75 kilohertz. What is the meaning of that? So the frequency of the carrier before modulation is, let us for example, the frequency of the carrier before modulation is 100 kilohertz. So what is the frequency of the carrier after FM modulation is not 100 kHz, it is changed. So this 100 kHz is maximum, it is changed to Fc plus Kf into Fc plus delta F. What is that? So 100 plus 100 kilo plus 75 kHz is maximum, which is nothing but 175 kHz, and a minimum is Fi minimum is 100 kHz minus 75 kHz, which is nothing but 25 kHz minimum. This is the minimum instantaneous frequency of the carrier after modulation. This is the maximum instantaneous frequency of the carrier after FM modulation. So this is nothing but Fi maximum, which is nothing but Fc plus delta F, and Fi minimum, now Fi minimum, which is equal to Fc minus delta F. This is the minimum instantaneous frequency of the carrier after FM modulation, and this is the maximum instantaneous frequency of the carrier after FM modulation. Okay, so this is means it will the changes, the frequency of the carrier after modulation is changing from 25 kHz to 175 kHz. This is 25 kHz and maximum is 175 kHz. Okay, so the practically the maximum frequency deviation is 75 kHz. Okay, note down this. The frequency of the carrier before modulation is Fc. The frequency of the carrier after modulation is Fc plus delta F, and this is Fc minus delta F. Before modulation is Fc, after modulation is Fc plus delta F, minimum Fc minus delta F. So what is the carrier swing? The carrier is, let us assume, for example, this is 100 kHz. I am already saying the maximum is 100 plus 75, 175 kHz, and minimum is 100 minus 75, which is nothing but 25 kHz. Okay, so the carrier frequency is changing. Before modulation is Fc, after modulation is Fc plus delta F to Fc minus delta F. Now this is called as carrier swing. Carrier swing. The carrier swing is Fc plus delta F to Fc minus delta F. Now which is nothing but 2 delta F. This is the carrier swing. Fc plus delta F minus of Fc minus delta. This is the carrier swing. The carrier swing is 2 delta F. And what is a modulation? how much modulation is done in FM? The percentage modulation, which is nothing but the actual frequency deviation, to maximum frequency deviation. So the percentage modulation is nothing but the actual frequency deviation, to the maximum frequency deviation is called as how much amount of modulation is done in FM. Okay, 20% modulation or 30% modulation or 100% modulation is nothing but, now out of a maximum frequency deviation, what is the actual frequency deviation of the carrier? Okay. Note. This is the instantaneous frequency of the carrier after modulation. Okay. So now you see here, this is carrier before modulation. Amplitude is AC, frequency is FC, phase is phi. Now this is carrier before modulation. Now this is carrier before modulation and this is called as angle. This is the angle before modulation. Now what I want? I want carrier after FM modulation, after frequency modulation. What is the carrier after frequency modulation? Now you tell me. Is there anything change in amplitude? There is no change in amplitude. Before modulation, the amplitude of the carrier. After modulation, the amplitude of the carrier will be same. Okay. So there is no change in amplitude. Then what is changing? Now this is angle before modulation. Now I am asking what is angle after modulation. This I am using word theta I. Instantaneous angle. This is instantaneous. This is instantaneous angle after modulation. Then is there any chance of changing the angle? Tell me. Now this is angle before modulation, student. Now is there any chance of changing the angle or a same angle you should be appeared? No. Definitely there is a change in angle because this angle is nothing but frequency and phase. This is angle or also called as augment. So this is the before modulation, carrier frequency is FC. After modulation, definitely the carrier frequency is changed. Therefore, the frequency is changing, this angle is also changes. So now I required what is the instantaneous angle after FM modulation. Okay. Now see here. So can I write like this? Now this is the angular frequency. What are the units of angular frequency? Radians per second. Radians per second. I just take instantaneous angular frequency, means instantaneous angle. So can I write like this? D theta I, which is equal to omega I into dt. Can I write like this? D theta I, omega is what? 2 pi Fi into dt. Now d theta I, which is nothing but 2 pi, what is Fi? Instantaneous frequency. What is instantaneous frequency? Fc plus Kf into m of t into dt. So d theta I, which is nothing but 2 pi Fc into dt plus 2 pi Kf into m of t into dt. Now if I integrate both sides, integration of d theta is what? Theta I, which is equal to 2 pi Fc, integration of dt is t plus 2 pi Kf integration of m of t dt. Now this is the instantaneous angle after FM modulation. This is the theta I. This is the instantaneous angle after modulation. Am I right now? Now you see here. Now when the instantaneous frequency is changing, angle is changes. Am I right? The instantaneous frequency is changing, instantaneous angle is changes. When frequency changes, see, you can easily understand. When the instantaneous frequency is changing, instantaneous angle is also changes. When this frequency is changing, we call it as, yes, the frequency is changing, instantaneous frequency is changing in accordance with the amplitude of the message signal. So when this instantaneous frequency is changing, which is nothing but frequency modulation, when frequency changes, this angle is changes, therefore this frequency modulation is named as angle modulation. Clear or not? So here also you can easily observe, when frequency is changing, this angle is changes. So this frequency modulation is called as angle modulation. Now students, I think one point is also clear to you. So sir, when frequency changes, instantaneous angle changes. Now at the same time, when phase is changes, instantaneous angle is also changes or not? Yes, obviously 100% correct. That's why when frequency changes, angle is changes. When phase is changes, angle is changes. That's why the frequency modulation and phase modulations are called as angle modulation. So of course, this is message is analog, carrier is analog, modulated signal is analog, continuous wave signals, continuous wave modulation, analog modulation. Now in that AM, FM, PM, again these two FM and PM are classified into separately an angle modulation, because when frequency changes, angle is changes. When phase is changes, angle is changes. That's why this frequency modulation and phase modulations are called as angle modulation. Now it is clear or not? Previously you have some doubt why it is called as angle modulation. Frequency modulation is happy, but angle modulation, now why it is, the name is comes into picture. Now I hope you understand the frequency modulation and phase modulation, why it is called as angle modulation, because frequency changes, angle is changes, phase is changes, angle is changes. Therefore these two modulations are comes under the category of angle modulation, and all these are comes under the category of analog modulation techniques. Okay, so this is the instantaneous angle. This is the instantaneous angle after modulation. What is the instantaneous angle after modulation? The instantaneous angle after modulation is 2 pi fct plus 2 pi kf integral m of t dt. This is the instantaneous angle after FM modulation. This is the angle before modulation. This is the angle before modulation, and this is the angle after frequency modulation. Okay, and this is the FM wave in time domain. This is the FM wave in time domain, and this is the FM carrier before modulation. This is the carrier after modulation. Okay, no doubt. Now this is FM modulator, means it will generate an FM signal when you give a message signal as an input and a carrier signal for modulation. Now let us assume the sensitivity of the frequency modulator is 5 kHz per volt. Now what happened? What is the frequencies produced by FM wave? FM wave means continuously frequency is changing when a message signal amplitude is changing. Let us see, for example, now m of t, which is equal to 0 volts. Then what is Fi? Fi, which is equal to Fc plus Kf into m of t. What is m of t? M of t is 0. Therefore Fi, which is equal to Fc plus 0 volts, which is equal to Fc hertz. Right? Now if m of t, which is equal to 2 volts, what is Fi? Fi, which is equal to Fc plus 5 into 2, which is equal to Fc plus 10. hertz. Now let us assume this Fc is kilohertz. Okay. So now see here, when m of t which is equal to 5 volts, when m of t equal to 5 volts, then what is the frequency? F5, which is equal to Fc plus 5 into 5, which is equal to Fc plus 25 kilohertz. Now if m of t which is equal to 10 volts, now what is this? F5 which is equal to Fc plus 5 into 10, which is equal to Fc plus 50 kilohertz. So what you can understand from this, now these are the voltage variations and these are the frequencies variations. What the FM modulator? The FM modulator is nothing but voltage to frequency converter. Voltage variations are converted to frequencies. Voltage to frequency conversion is nothing but FM modulation. FM modulation. FM modulation is the frequencies changes corresponding to the voltage ranges. Okay, for every voltage changes is which results in the frequency changes. Now if m of t is maximum, frequency is maximum. If m of t is minimum, frequency is minimum. Understand or not? So every voltage variation is converted to frequency variation. This is nothing but FM modulator. Simple example. Now the same thing which we will see in the waveforms also, everywhere the message signal amplitude is changing, so everywhere the carrier frequency is changing. When m of t is maximum, Fi is maximum. When m of t is minimum, Fi is minimum. Okay, hold on. Now what is the time domain equation of FM signal? Now this is the FM wave in time domain. Now see here. Now this is the FM wave in time domain, which is equal to AC cos 2 pi fct plus 2 pi kf integral m of t dt. Now which is equal to s of t of fm, which is equal to AC cos of 2 pi fct plus 2 pi kf integral m of t is am cos 2 pi fm into t integration dt. Therefore s of t of fm, which is equal to AC cos of 2 pi AC cos of 2 pi fct plus 2 pi kf into am. Integration of cos is sine, now divided by 2 pi fm into sine 2 pi fm into t. Therefore then the FM wave in time domain, which is equal to AC cos of 2 pi fct plus 2 pi cancel kf into am by fm into sine 2 pi fm into t. Therefore s of t of fm, which is equal to AC cos of 2 pi fct plus, now see here, what is kf into am? The kf into am is nothing but the frequency deviation by fm into sine 2 pi fm into t. Now delta f by fm, s of t of, now this is delta f by fm, the frequency deviation to the message signal frequency. The ratio of frequency deviation to the message signal frequency is called as modulation index beta. This is modulation index in FM. Okay, there is a modulation index which we already have an experience in AM. So in modulation index in AM is mu, which is equal to Ka into AM, which is used for demodulation process. Am I not? So the modulation index in amplitude modulation is used for the demodulation of AM, which is nothing but we are using that mu in the envelope detector or a demodulation process. But this modulation index is not used for the demodulator. This modulation index is especially used for analyzing this FM signal and analysis of FM spectrum. Okay, and there is no use of modulation index in DSB, SSB, VSC because all suppressed carriers, no envelope detector. No envelope detector means no modulation index. Okay, this is the modulation index. Therefore, what is the standard mathematical time domain equation of FM? Finally, the standard mathematical time domain equation of FM is, now see here, this is the standard mathematical time domain equation of FM signal, AC cos 2 pi fct plus beta into sin 2 pi fm into t. This is the standard mathematical time domain equation of FM signal or FM wave in time domain. Note down. Now see here, S of t of FM, which is equal to AC cos 2 pi fct plus beta sin 2 pi fm into t. This is the standard mathematical time domain equation of FM signal. Now based on modulation index beta, so when this modulation index beta, if this modulation index beta is less than or equal to 1, this is called as narrow band FM. If this modulation index beta which is greater than 1, this is called as wide band FM. This is beta which is greater than 1 is a wide band FM. If this is beta which is less than or equal to 1, this is narrow band FM. So we will see both narrow band FM and wide band FM. Okay, but which is best and which is not good, which is good, we will see. And what is the instantaneous angle? This is the instantaneous angle after modulation is important because this is angle modulation. 2 pi fct plus beta sin 2 pi fm into t is the instantaneous angle after modulation. Now this is theta which is equal to 2 pi fct plus 2 pi kf integral m of t dt. This is the instantaneous angle now after FM modulation, which is equal to, this is 2 pi fct. Now this is the instantaneous angle after FM modulation. Okay, this is the instantaneous angle after FM modulation. Now first we will see now when beta less than 1, this is called as narrow band FM wave. Okay, first you note on this. This is narrow band FM wave. We will see now. Now this is the equation S of t of FM which is equal to AC cos of 2 pi fct plus beta sin 2 pi fm into t. Now see here, AC, expand this one, cos of A plus B, cos A cos B minus sin A sin B, cos A cos B. This is a FM signal. Now let us assume here, what is theta? Theta which is equal to beta into sin 2 pi fm into t. Now you know that when theta is far less than 1, sin theta is approximately theta and cos theta value is approximately 1. When theta is far less than 1, when theta is a small value. So here what is theta? Theta is nothing but beta is less than 1. So how I can write? Now this is the narrow band FM. Now the narrow band FM wave which is equal to AC cos 2 pi fct, theta value cos of theta is 1 minus AC sin 2 pi fct, theta value is nothing but beta into sine 2 pi fm into t. This is the narrowband FM wave. Note on this.